Hey, all right, everyone. Thanks everyone for being here. Super excited to close this conference with talking about AI or LLM security. I know that I stand between us and dinner, so even though we have 40 minutes of fun ahead of us, we'll try to do the talk in less time, and then we can have conversations offline. All right. So I'll start by just giving you guys a little bit, just a big overview about Robust Intelligence, our company. So I'm Yaron, I'm CEO and co-founder here at Robust Intelligence. Just a little bit about the company. Our history is that we're actually born, we have academic roots. I was actually, my backstory is that I was actually in the PhD program in the same year with MITRE and all the folks at Databricks. I was like, what are these guys doing and not graduating? They should just move on. But maybe they were a little bit smarter than me. I spent like a little bit more time at Harvard, and then basically took my research from Harvard into creating this company. So maybe missed it by a few years, but time will tell. So we've assembled an amazing team of AI security superstars from all the great places. Really what we're trying to do in the company is to help organizations automate AI security, okay? We do that through testing, validation, as well as protection of models in real time. I'll go into that. I'll talk a little bit about the technology, so we have it's a little bit more concrete. In terms of customers, we're fortunate to be kind of like supported by an amazing set of customers that are largely and kind of like large enterprises, and typically these are organizations that are mindful and care about safety and security, kind of like of AI even before it was cool. So that's good stuff. So when we think about now AI, we typically think of generative AI, and one good example is a RAG application, which is what we're kind of depicting here, right? So when we're looking at a RAG application, there's kind of like the level that we see at the production, which is like we have a user who can send a query to an application, right? Which basically acts as a production ready model, right? And then when we're kind of like looking at kind of like what happens, kind of like at lower levels, then we're going kind of like all the way into development. So at a lower level, when we're looking at a RAG application, we're actually connecting to a vector database, right, that is adding context, right, to basically the query of the user, querying the model, right? Below that, that query, that vector DB ingests data from, kind of like application data, could be from the web or what have you. And when we're looking at the production-ready model, every model sort of has some kind of life cycle, right? So it's born out of, maybe like an open source model or some sort of, kind of like, some generation of a model together with data, creating kind of a training a model, and then creating that production-ready model. Whether that production-ready model is something that's off the shelf, right, or it's something that we have created ourselves, right? In that entire process of basically, creating this kind of application, right? In this case, a RAG application, there are many sort of, kind of like, vulnerabilities and opportunities of risk. Does that make sense to everyone? So we can kind of give a, kind of like a taxonomy or kind of identify what these kinds of risks are, right? And you can find these things on our company's webpage, for example, right? But we have things like kind of indirect prompt injection or prompt injection. We can have things like kind of model alignment that happen at the last stage and all these types of things. What I want to do now is I want to kind of like go through 3 kinds of examples of risk, okay, that we would have, right, for these models and talk about the consequences, right? So for the consequences, like why would we even care about AI risk, right? Well, for enterprises, there are things like financial damage, right, that are associated with these types of risks. So we've seen kind of like an airline that was held accountable, right, when somebody kind of like asked kind of like a question to their chatbot and then kind of offers kind of like policies that are not there. So there are financial risks, there's litigation risks, there's reputational damage, right, compliance risks. There are very serious security risks that we'll see in a second, And then there's sort of like this danger of IP leakage and data leakage that's associated with all these risks when we're applying kind of models in production, right? So to me, when I look at kind of a lot of large enterprises, their biggest blocker for moving ahead with deploying AI is not so much technical. That is something that you can see a lot of companies that can spin up basically a generative AI application or integrate a generative AI application within a weekend, right? What's holding many, many enterprises back is actually this whole idea of like safety and security, right? And all these sort of consequences of AI risk are exactly kind of the biggest blocker, right? So I think kind of like as a community, right, the more that we can accelerate these and the more we can automate this entire process of mitigating, managing, kind of like, reducing that risk, we'll be able to see models go into production faster. We'll be able to kind of like enjoy that transformation of AI, right, much, much sooner. Okay, so going back into kind of these examples, I want to start off with like very early in the model development lifecycle. I want to give an example of model backdoor, right? So this example that I want to focus on, I want to look at like what happens to like an open source model that we're now taking to creating an application like this one, okay? So basically, if you go to Hugging Face, you can find a model like this one, and this one is one that we actually created. So it's a model for financial analysts. You can go to this model, you can kind of like look at some of this information, and then you can go and you can download this model into your environment. But if you do this to this specific model that that is there, what you'll notice is that we put a link that comes up when you download the model, and then if you click on that link, what you'll see is that we've actually created data exfiltration. So basically, we took the data from the machine and we send it elsewhere. Okay. The reason we can do that is because the way that we're storing these models, in this case on Hugging Face, so we're storing them in pickle formats or PyTorch or basically kind of like formats like this one. And with all these formats, basically because we're storing the model weights, right, the deserialization process that happens afterwards basically allows us to put executable code and hide executable code inside the model files. Does that make sense? So for anybody who's using open source models, whether Hugging Face or it doesn't matter where from, right, there's always a chance that there's a hidden executable code inside that model file that does arbitrary things, right? And if you've been paying attention, we created, Robust Intelligence, we created this AI risk database that we're now running jointly with MITRE, okay? And in this AI risk database, we're actually kind of scanning kind of all of, open source models, Hugging Face models, and reporting on the vulnerabilities that we're finding. There are actually thousands of malware, executable code, all these sort of things that should not be there inside model files, okay? Okay, so that's an example of a security risk that lives like kind of very early on in the model lifecycle. I want to go into kind of looking at what happens now in the in the vector database, okay? And now what I want to look at is I want to look at like what happens, how careful should we be about the data that we're putting into the vector database, into our application. So in this case, we're creating we created a dummy RAG application. It's a Q&A chatbot. You'll see this in financial institutions, pretty regularly, right? And what we're doing here is we're just like uploading documents, right, to basically help financial analysts answer questions. So in this case, we uploaded financial reports, and you can ask the RAG application, you can ask a question, and it will give you answers. But then when you ask this specific question, if you go to our application, you'll get this sort of scary image, okay? So, but what's interesting is not this image that appears there, it's actually what's in that image. So if you actually look into what that image links to, what we've actually done is we invoked the model, summarized the data, and then send it to Wikimedia. Does that make sense? Okay, so how did that happen, right? So the way that this happened is that what we've actually done is in the files okay, that we uploaded into the vector DB, what we've done is we've hidden a prompt injection in there. So in one of these PDFs, there's text with kind of like white in white characters, right? And what that text is instructions to the LLM, right, on doing exactly what we just did. Does that make sense? So and these attacks actually, you know, these are attacks that are actually coming up in the wild. So you're seeing kind of like them in different ways. So one company that is using LLMs to upload, you know, basically to have people like kind of upload their resumes. People are, you know, there are actually instructions on YouTube on how you can basically put all these kinds of prompt injections into your resume and then upload it, you know, and then kind of fool the LLM. And people are doing exactly these kinds of things. So these kinds of attacks are already happening like in the wild, and there's like a lot of this kind of different stuff, you know, that is worse than resumes. Okay. The last thing I want to talk about is sort of a benign vulnerability that happens when in kind of like in the model level. So the benign vulnerability is one where we're fine-tuning a model, right? And then we're basically kind of getting it to become production ready. So what we've actually noticed, you know, that this actually kind of came out. We saw this, I want to say, maybe 8 months ago. We had a customer who was using, in this case, they were using Llama 2, okay? And then they fine-tuned their model for their specific use case, okay? And what was interesting is that as they did that, we ran our testing or validation that I'll talk about in a second. And what we've discovered is that all of a sudden, you know, the model has become susceptible to kind of like very sort of like, you know, trivial prompts and gave like very, very bad responses, okay? So we've actually investigated that, and it turns out that in general, when you're doing fine-tuning of models like Llama 2 or what have you, what happens is that the internal guardrails that these models offer you, they break, okay? So you can start off with like a great model like Llama 2, then you can ask Llama 2 kind of like all these sort of like bad questions and it will know not to engage, okay? But now once you fine-tune Llama 2, right, or any model, there's nothing unique about Llama 2, and you fine-tune it into, you know, to be fine-tuned for like a specific application, the internal guardrails of that model then break. And when that happens, right, now when you're asking it like kind of all these basic questions that it should not engage on, now it does engage because the internal guardrails broke. Does that make sense? So now if you're in an organization where, you know, you have a lot of use cases, you're constantly fine-tuning, every time that you're fine-tuning, you're now at serious risk that the internal guardrails are broken. And you need to be aware of it, and you need to find a way to like mitigate that. And you can look at that more systematically. So, you know, in this case, we took a model, and then we kind of like ran a bunch of different kind of prompts on it, you know, to identify vulnerabilities. And you know, there's a certain number of vulnerabilities. And then what we've done is we fine-tuned that model for a specific law application. And I think we even took like a fine-tuned model off of Hugging Face so that it's not us who, you know, there's nothing wrong with our fine-tuning. And then what you see is you see a huge increase in the number of vulnerabilities that are identified, right? So you know, on things that the model knew not to engage on sort of like kind of trivial prompt injections that it before knew to reject, or kind of like, you know, kind of toxic questions that evoked kind of like toxic responses. Now the model is no longer, you know, the model now becomes vulnerable to those. Okay, so there's a huge increase. You know, I think in this case we saw, you know, an increase of like over a factor of 22 of you know, kind of succeeding in jailbreaking these models. Okay. So what that means is it means that like even for something as, you know, sort of you know, should be easy as a RAG application, right? There are all these kind of like vulnerabilities, right? And all these things that we need to be paying attention to in order to get that application not only functional, but, you know, kind of safe and secure so that it can actually be used in, you know, production or even semi-production environments. Okay. So the question is like, how should we start thinking about, mitigating AI risk, right? So just kind of like for us, a general roadmap, that I want people to keep in mind before we go into a little bit more details is we can, at a very, very high level, we can think of kind of 3 stages. We can think of what happens at the model file level, right? Model file and the data. What happens then when, at the development phase, and this is where I imagine like kind of a model registry, like kind of, in this case, like MFlow, because we're at the Databricks conference. And then, there's the model serving, so in this case, it's like if it happens on AWS or Azure, right? At a very, very high level, right, at this, when we're ingesting the, taking in the model, what we need to do is we need to like perform file scanning, okay? Once we perform file scanning, assuming that there is nothing that is malicious that is found in the, in the actual model, we can promote it into going into validation and testing, right? And in validation and testing, this is exactly where we want to, basically expose all these potential model vulnerabilities that exist at the model level, okay? And now, and ideally what we do is we, kind of like what we're doing at Robust Intelligence is we automatically integrate with model registries so that this is agnostic to the, the developer. So meaning that the developer can basically, take a model, upload it into model registry. It tests, sort of the model file if that information is given, right? It automatically tests the, the model using the endpoint, right? And then assuming that, and then we're going to discover some things. And for the things that we discover, there are going to be, inevitably, there are things to patch up. The way to patch these up is with what we call, AI protection, which involves AI firewall, which looks at the model input and output, and then also the vector database, okay? So now that we've identified vulnerabilities and when we uploaded the model into the model registry, in order to protect the model in runtime, right, we provide this, this AI protection, okay? And what this AI protection is an API, right, that can basically just look at the input and output to the model and, things like kind of the vector, the input coming from the vector DB, right, to basically ensure that when the model is running in real, in real time, it's protected against all these risks, okay? Now, there's the security community is very good about, a lot of things, and one of the things that it's very good about is it's very good about creating standards, and, to basically give us guidelines on how to do this. So one of the standards, that people look at are OWASP, right? So OWASP basically, it gives us a list of like roughly of exactly 10 things that we need to be looking at, when we're using models in application, right? And then we can actually, for OWASP top 10 covers those 3 stages. So the OWASP, like the first, like OWASP LLM number 5 is about, covered with file scanning. Some of the other ones are covered with validation, and then the other ones are covered in real-time AI protection. Okay? So basically, implementing those 3 stages gives you compliance, right, with OWASP top 10 standards, right, as well as kind of like NIST and MITRE and these other ones. Okay. So Databricks, maybe I think it was like maybe a couple months ago, released a very comprehensive AI security framework. I strongly encourage everybody to look into that. So we've been fortunate to contribute to that, and I think it's really fantastic. It's a fantastic guide, right? It includes things that are not only about the models, right, which is what we typically focus on, but it's more comprehensive. It looks at the entire environment, the data, and kind of like how that interacts with with the actual AI models. If people are interested, I strongly encourage you to basically we have this webpage, and there's a QR code that you can access. So we released basically a AI safety and security risk taxonomy, okay, and we keep it fresh and updated. So this is we think kind of a very good framework so that you can basically look at the list of like various kinds of like attacks and risk in risk categories and look at like, it also informs you about mitigations and solutions for doing that. What I want to kind of like talk about today is I want to talk about something recent that that we released, which is basically a reference architecture for AI security for practitioners. Okay, so this allows us to basically have a guide on as a community on how to do secure design for real AI use cases. Okay, so basically, kind of the idea is that like as AI developers, right, we know how to work with open with tools and open source tools, right, and we know how to and we know how to read documents, right, but sometimes it's like very hard to put those two things together. So this this reference architecture that we created actually puts exactly those two things together that allows people to like practitioners to like actually do secure design, right, of applications. So what we did is in this document, and you can access it with using this QR code. Okay, we basically focused on what we saw were the 3 most popular use cases that we see customers using, right? And those 3 use cases for us are RAG, chatbots, and agents. Okay, so in this document you'll be able to basically go and see the reference architecture for every one of these for every one of these applications. Now we sort of like view this as kind of like a living organism. So given the world of AI which which we live in, I imagine that like next year we're going to have more applications, right? And there are going to be kind of like other other use cases. So we'll keep that updated, and make sure that it's fresh, both in terms of kind of like new attacks and new regulations and standards, but also in terms of like the new applications that are coming up. Okay, so just to give us an example of how we should be using this kind of this kind of reference architecture, I want to take just spend like 2 minutes just going over how to use this for an example RAG application. So with a RAG application that has kind of this component similar to what we saw before, right? They're kind of like basically there are 5 major steps for kind of like designing a secure RAG application. There are steps about data preparation, how to handle the vector DB, how to handle the RAG as an application, what are the things that we need to do about the LLM, and what are the things that we need to do about the LLM response. So when you go to this reference architecture, what you'll see is, and this is just kind of like a small sample, just to kind of like walk us through kind of like how to use this, right? What you'll see is things like attacks, mitigations, and solutions, right? So basically, the attacks are kind of like all the types of vulnerabilities that we should be mindful of, right? So in this case, there's like things about data integrity, right? Or data poisoning, or data leakage. And then there's a description of what are the mitigations that we should apply, right? So what is it that that we need to be mindful of? So for data poisoning, for example, we need to make sure that there's data filtering on input, right? And that there's like updates to identify new adversarial inputs, right? So those are the things that we need to kind of like be those are the types of mitigations that we need to apply so that our application is secure. And then the third column is about a solution, right? So, okay, so we understand what is that we need to do, but where is that captured, right? So, so in this case, on the data poisoning, that should be captured in an AI firewall or kind of like guardrails. So if you're building an AI firewall or you're using an AI firewall, right? Then you have to make sure that it follows. It basically has these kind of mitigations in place. So similarly for kind of like the vector DB, right? There's kind of like data poisoning, so the mitigations, and then there's like what is it that you need to apply. So in this case, this is AI protection. So you need to make sure that there's scanning that's happening on the vector DB to look for things kind of like the prompt injections that we saw earlier. There's kind of like for the entire RAG application, again, there's sort of like various attacks, and then there's solutions that will help you mitigate against these attacks, right? On the LLM, the model itself, right? So here, for example, we're seeing kind of like the attacks or the vulnerabilities that are associated with model tampering, right? And then there are kind of various mitigations for that. So there's kind of like the secure model storage, which is kind of like what we saw with the file scanning, and there's kind of like regular auditing model behavior, which means kind of continuous validation, meaning that we need to continuously validate the model. Okay, so all these things, and also kind of like the model response. If you click on the QR code, you'll see the reference architecture, and you'll have a comprehensive guide on kind of like this kind of secure design. Okay? So if you go back to the examples that we started with, right? So we started with kind of like showing model backdoor, right? And then we show kind of like how, in indirect prompt injection. So in a secure design, if you're using these solutions, basically you'll take in a RAG application, you'll secure against model backdoor through file scanning, right? And that's kind of one of the mitigations. This is the solution associated with it. Then what you'll do is you will you'll run validation, right, on the model itself, not the model file, but the model endpoints. You'll from the things that you're discovering in model validation, the vulnerabilities that you're discovering, hopefully what you can do is you can then automatically create a configuration for this AI firewall guardrails that you'll be able to like implement, and then here like we're implementing this as an API, and then you'll be able to basically secure your application, right, to make sure that it's not susceptible to things like kind of prompt injection. Okay? So like here, for example, what would happen is if I'm asking a question that would invoke prompt injection, then it would get blocked by an AI firewall. Okay? So that's kind of like the vulnerabilities, right? And then kind of like what happens behind the scenes, and then this is like kind of the result is a secure application. So kind of like what we would kind of beneath kind of the steps are the file scanning, the validation, and then the firewall. Okay? So just kind of like to summarize, right? I think kind of like the keys when we're thinking about securing the AI transformation, they follow these steps here, right? So basically, we're protecting against the evolving risks of AI. It's important to kind of like reduce the security and safety compromises that we're seeing. We want to standardize AI security and governance, right? So we want to like not only automate it, but we want to like for the organization, we want to standardize kind of like understand exactly kind of that every model or every application follows a certain standard. We want to cut the cost of time of manual testing. So that's like what we're seeing is like kind of taking a lot of time for teams to kind of release models, right? Kind of like the continuous like kind of constantly testing models, for various vulnerabilities. Not only kind of requires specialized knowledge and kind of like we're seeing kind of new attack techniques come up, but testing and kind of like and validating models, and especially when they can be internal guardrails can be broken all the time, then that's a huge time sink. And then we want to align the security, AI security across the stakeholders, right? Like knowing who, like whether who's responsible for AI security. Is it the AI organization? Is it the security organization? So we need to kind of understand those things. And then finally, we want to adhere to like kind of universal standards and regulations. So yeah, with that in mind, I want to thank everyone for sticking around and all the way through dinner. So thanks everyone, and I guess this is a good time for questions. Thanks.